Okay, it looks like we're live. So, hello world, hello, and welcome back, and keep this paused. So, on the next thing, beautiful triplets. So the last one didn't take too much time. These are now easies we're looking at, and this time around, let's get right into the problem. HackerRank, we're going to use Clojure, get a little more comfortable with Clojure, do some easies. So we said we'll do 7 more problems. So this is, let's say, number 7. Given a sequence of integers a triplet a of I, a of j, a of k is beautiful if I is less than j is less than k, a of j minus the difference between a of I and a of j is equal to the difference between a of k and a of j, which is equal to some d, some constant difference. Okay, fair enough. Given an increasing sequence of integers and the value of d. Given an increasing sequence of integers and the value of d, count the number of beautiful triplets in the sequence. For example, the sequence array 2, 2, 3, 4, 5, and d equals 1, there are 3 beautiful triplets, which looks like 2, 3, 4, and 3, 4, 5, and these are sequences, so they can be out of order. So you could do 2, 3, 4, 3, 4, 5, what's the third one? 0, 2, 4? Excuse me, is there supposed to be a 0 here? Is this just incorrect? 0, 2, 3? Wait a minute, what? There are 3 beautiful triplets by index. A of k minus a of j. Oh, I'm so confused. I, j, k, 0, 2, 3. What? Oh, wow. Oh, that is so confusing. Okay, I understand. Gotcha. I thought this was different than, alright. So the triplet is the triplet of the indices, and the idea is you take 3 indices, and wait a minute, am I just really confused here? A of j minus a of I, so this 2 and 0, 0, 1, 2, 3 minus 2 is 1, and then, so we have 2, 3, oh, I understand now. Okay, got it. So they're going, yeah, no, I had the right idea. They're saying you can, but these indices don't need to be consecutive indices. That's the thing that I'm missing. So 2, 3, 4 is correct, 3, 4, 5 is correct, and then 2, skip this 2, 3, and 4 is also correct. That's what this first one is. 0, 2, 3 is 0, 2, 3. Okay, I was like, really threw me off. But I understand now. Okay, fair enough. Complete the beautiful triplets function. The editor below must return integer that represents the number of beautiful triplets in the sequence. The following parameters d and integer are an array of integers sorted ascending. And we'll read these briefly before I comment. First line contains 2 integers, and in d, the length of the sequence beautiful difference. And the beautiful difference. Interesting. Let's talk about those beautiful differences. Okay. Second line contains n space separated integers. Okay. Which is the array. We got constraints. N is, looks like 10,000 numbers. The difference is between 1 and 20. The values of the array is going to be between 0 and 20,000, and it's an increasing sequence, always increasing sequence. Print a single line denoting the number of beautiful triplets in the sequence. Input, output is 3. So we just need the number of them. We don't need to enumerate all of them, which is enumerate and print or enumerate and return all of them, which is very different, right? You can easily count very quickly the number of permutations of a set of things, but you cannot easily print all of the permutations. You can count how many there are, but you can't print all of them. One is significantly more computationally expensive than the other. Explanation sequence. So okay, so for this sequence we would say, like, let's see, can we do? We can't do 1, 2 anything because all of these are further than 1 from 2, right? Can you do 2, 4 anything? Can you do 1, 4 anything? So 1, 2 won't work. 1, 4, 7 works. 1, 5, there's no 9. 1, 7 doesn't work. Actually, that's it. The maximum is so actually it's 1. So you could stop at 1, 7. If you say, so you get 1, 5, 1, 4, 7 works. How about 2, 4? There's no 6. 2, 5, 8. That's a second one, and then 2, 7 after that. Right, our maximum at the end. This already exceeds the maximum, so we can forget checking after that. How about 4, 5? We don't have a 6. 4, 7, 10, and that's got to be the end of it, right? Because 4, 8 after the maximum 10 is less than what you need, which is 12. So you're done after checking 4, 8. Yeah, after 4, 7, 10. So those are the three options. Now, obviously, that was a pretty simple brute force algorithm I just described to solve it. Now, I don't have a particularly good idea how to solve it without using something like that. That's like a double loop, a double for loop type of deal, which would not be efficient enough in this instance. You want something that's slightly more efficient. I'm fairly certain you can do this in linear time. I'm curious though how this can be done, because it's, well, actually this can be done a lot more efficiently than we realize, and I will describe for you how and why. Yeah, this can be done in linear time, definitely. Well, you can do it in n times d time, which is kind of a hack, but because they gave us a d, it's just kind of made it a lot easier. So in theory, what you can do is say, okay, put all these things into a hash map, and yeah, you can put these things into a hash map, a frequency map, really. And what you would say is, for each n, we're going to try each d. For each of these values as a sort of the starting point. Just try every d and see if you can get something that works. And you're going to multiply through the frequency map for each success and summate over all of those successes, if that makes sense. That would do it. That'd be a pretty efficient way to do this. Are there other approaches? Probably, but being that we've just kind of deduced that one, I think we'll just go with it. So I'll show you what that looks like. Yeah, let me show you what that would look like. So first things first, let's go ahead and define, we're going to use let to sort of do this somewhat imperatively, and then we'll say frequencies of array. Then we want, it's actually kind of simple here. It's going to look something like this. It's going to be a sum over, we're going to range, well, keys, it's really it's going to be frequency or keys of the frequency, right? And what we're going to do is say, I'm going to multiply three things across. 1, 2, 3, and they're going to be excuse me. What do they call this when you apply a function over, how does that work? When you map, that's what we're looking for. I want to map, and then we're going to apply summation. I think I can use, apply some. I want to map this, and we'll call it, this anonymous function. Yeah, that's fine. Let's do this. Actually, it's not going to be anonymous. It's going to be possible triplet, or just triplets. Triplet product. That's what we want. All right. What this is going to look like is. By the way, I like this as well, this style. Kind of do it like this. And we got this function. That's all well and good. What we're going to return is frequency. So you've got key, right? And you're going to say let, again, we do this imperatively. Functions within lets within other functions, sub-functions. Oh, is what it is, I guess. So initial value is going to be frequency of key, or val1 or v1, we'll call it v1. v2 is going to be frequency. It's going to be frequency of v1 0, and v3 is going to be frequency of v2 0. So you return 0 if you don't find the key, right? And then you're going to return the multiplicand of v1, v2, v3. Now there may be a better way to do this. I think what you want is probably yeah, it's kind of interesting. You're going to multiply across frequency of key times frequency of the key times the frequency of the, and actually it's even more than that. It's going to be v1 is the frequency of the key. This isn't v2, v1 rather. This is going to be the key plus triplet product key and then d. I did it wrong by the way. That's what we want, and then we want plus key dd, and we multiply these across. So actually, this is maybe like a nice reduce we could do. Wondering if there's a way to kind of simplify this. But this will be for each d, and then we want to range over all the d's so we can give. There's like triplet product of d. Something like this. Which is going to be it's maybe sort of this for each D. Actually, this may just be another anonymous function here, which is, oops. What this is going to look like is count triplets. Given some D, right? I mean, you could set up this loop either way. Here we're going to use, given a certain D, we count the triplets, but you could also write this function as given a certain key, and then loop over all the possible D values. What we ultimately are going to return is, if you range over D, it should be the increment of D plus, well, it should be 1 to including D, right? And use sum over this map of count triplets. Yeah, that ought to do it. This is supposed to be an easy problem, but I find myself kind of stuttering and stumbling. Well, I'm looking for like a really compact way to do this. Probably a way to do this in like one line, probably even in Clojure, like a few lines. But in Python, probably could do this in one line as well. But yeah, something like this ought to do the trick. See if it compiles. Excuse me. Wrong answer. Right answer. Output 8, expected output 2. Nice. Oh, they give us D. Oh, there's only one D. Oh. Wait, what? Oh. Wow. Oh, excuse me. That makes things a lot more interesting. Well, in that case, you don't need this. You can just return count triplets of D. Nice. Okay. Neato. Does this work? So I actually solved a slightly harder problem, which was, well, we solved both of them, but solved this one and a slightly harder problem, which is, you know, looping over all possible D, like all the D that we care about, which there's only 20 of them, so it's kind of straightforward. Oh, wow. Okay, that was pretty easy, huh? More efficient way to do this, or just a cleaner way to do this? Well, certainly we can just copy paste this here immediately. And then this triple product thing is kind of interesting, because I think we can think we can just sort of paste each of these into this part right in there. Right, so the way this is done, or had been, how I've done this, is where you have v2 or v3 and all of that. This extra is 0. If you cannot find what you're looking for in the map, you'll get a 0 instead, which will make this whole multiplicand 0, which when you sum over that is kind of easy to work with, we'll say. And D is even provided for us, so we don't even need this D here. And this key actually just becomes, you can make this an anonymous function and just call that this guy. Yeah, you end up with a situation where, what was it even saying? I don't remember. Yeah, kind of works out nicely if you do that. Obviously, this is always going to return because it's a key from the frequency map, so you're always going to find that first value, but these ones may or may not be there. So it makes things a lot easier, I think. You can just reroll that. Okay, you can see this is what the easy would look like now, rather than sort of the quote-unquote medium, the slightly harder version, the one that I tried to solve initially. Yeah, that's pretty terse. Kind of looking for a way to, I guess I was kind of looking for a way to like make this kind of systematic. These three values, make this like like an iterative function of some kind. You could, I guess, have like a transduction in here, where you're sort of, you can iterate over 0, 1, 2, and what it does with 0 is adds d 0 time, or adds a d times 0, or yeah, and then this 1 time adds d times 1, and then second time adds d times 2, and then tries to get the frequency with 0 as the default. Right, and that whole thing where you see you have a transducer that can sort of produce this multiplication, I guess, given this value. So maybe you could provide a transducer for arbitrary, like more than just a triplet, sort of arbitrarily long, not arbitrarily long, but some constant size tuple, rather than so a tuple of, like this triplet would be a tuple of size 3. You could use like sort of the same algorithm but for an arbitrary sized tuple, and solve this that way too if you write a transducer. Provide it with 3 as the argument. That can be done relatively easily. It's kind of neat. Kind of a slight variant on the problem. But yeah, let me end the stream here too. That's pretty good. Thank you all for watching. Talk to you soon. That's the 7th problem, so now we'll have the 6th problem in the next one. Let's see, maybe we'll pick an easy one, I suppose. Minimum distances. Come back to this one next.